Alright, good morning everyone. Welcome to week 7. I hope you're doing well. There's a lot been happening, an awful lot been happening. Alright. Well, since we last talked, the COVID situation in New South Wales has got significantly worse, judging by the numbers getting reported every day. Please stay safe. So, no surprise, we're not back to face-to-face tutes and labs this week. Nothing's happening on campus, so yeah, you shouldn't be coming to campus unless there's some very exceptional reason. No classes are happening on campus, so no COMP1511 tute labs on campus this week, and there's no announcement, nothing official yet for next week or the week after, but we're going to have to be incredibly lucky to be back even the week after next, I would think. So until you hear otherwise, everything is happening online. The good news that I said is we're one of the better placed courses in the whole university to cope with being online, so we'll try and look after you online. Alright, also I guess two things. Yeah, UNSW looks to its students to be many things, but one is we're looking to you be the future Australian leaders, and you can start now by setting an example with COVID. I guess we worry about two things. You're young and healthy, and COVID's not likely to be a problem for you unless you're unlucky, but you can certainly pass COVID to someone else, people near and dear to us. So we behave in a way that won't pass COVID on and won't help COVID spread through the community, affect the less young and healthy. The other thing is all the messaging about COVID is quite complex. There's all sorts of exposure sites and so on. So another thing you can do is make sure all your friends and family know about where COVID's been and where the exposure sites are, and help them understand that and make sure they know about that. Alright, assignment 1. Oh, well, not just COVID. Yesterday was really quite exciting because we also had a power failure that took out about 5 Sydney suburbs, including the UNSW campus, and CSE servers are all hosted on campus. You may have noticed that some UNSW servers stayed up despite there being no power in Kensington. That's because they're hosted off-site, somewhere out near Homebush, I think, at an official government site. So they stayed up, but all the CSE servers are actually in the K17 building currently. We're moving a lot of them off-site very soon. So they went down, and it's quite a complicated business bringing them back up. So there was no class web pages, no VLab server, no Give, and so on for about 5 hours, I think it was, 4 or 5 hours yesterday. So we extended all the deadlines for this week to give you a bit of extra time. So assignment 1 was due 5 minutes ago. Don't panic, there's a little bit of a grace period, so if you've forgotten to do that last give, you might dash off and do that last give. But assignment 1 was due 5 minutes ago. The week 5 lab exercises, hopefully you did those a long time ago, but you actually had until 5 minutes ago to submit those. Again, there's a slight grace period, so if you haven't submitted the week 5 lab exercises, you might dash those off. Also, remember, if there's sort of small problems in your life, you miss a deadline by 3 hours or something like that, your tutors can always help with little problems. Bigger problems you can email the class account, but little problems your tutor can sort. Other thing due this week is our weekly test from way back in week 5. Again, you might well have done that. Or maybe working on the assignment, you've left it, but you've got until Friday, first thing Friday, 9 AM Friday, to do the week 5 weekly test. And of course we'll have another weekly test coming out soon, and sadly, there's not much time in a 10-week session, so there's another assignment coming out pretty soon as well. Plus this week's lab exercises, there's a lot in this week's lab exercises. Actually, I really like this week. I think these are perhaps the most interesting of the lab exercises in one way this week, but there's certainly a lot of work in this week's lab exercises, so sorry you can't slack off. I guess you're locked down, but even if you weren't locked down, you might not have time to do very much outside the house anyway, with all that's happening in uni at the moment. Alright, so many of you are like me, locked down with your family, and that's not so bad. We know from last year and into this year, some students aren't in that fortunate position, and lockdown's pretty tough for them. They're one way or another, they're sort of alone in lockdown. This is a reminder, UNSW has some excellent support services for students. Whatever the sort of problems you're having, UNSW has excellent support services for students. And Tom put the link, I think, in his most recent email, probably in his most recent 2 emails. So if you look at the class announcements, there's a link there for UNSW Student Support Services. Or honestly, if you just Google, UNSW has that sort of stuff linked in pretty well. So Google UNSW Student Support. Don't hesitate to reach out to them if you're an international student in Sydney alone, or someone who's is locked down without the support they need and not coping well. All right. Yes, as I said, we heard from more students and staff who didn't cope so well with the lockdown last year. And we may be in for a few more weeks, as you can guess. I think that's all the admin announcements. I have to do some thank yous. Some excellent forum support led by Shrey, who seemed to be answering forum questions right through the night with assignment 1 coming in. He seemed to be answering questions at 4 a.m. Which is going. We don't promise to have someone in the forums at 4 a.m. but Shrey seems to have managed that, and a few more people have been stepping into the forum as well, and in the help sessions. The help sessions were incredibly busy, so a big thank you to all the tutors who were staffing the help sessions yesterday. Today, Tom's taking a break shortly from listening into the lectures and making sure I tell you all the things you need to know, and we've got Alvin, who's going to instead be my companion in the lectures today. So thank you to both Tom and Alvin. So I'll ask Tom and Alvin, are there anything else of general interest I need to announce at the moment?
Not from me.
That was Alvin's voice, if you haven't heard it before. And Tom, are you still with us?
Yeah, I can't think of anything else safe, possibly for mentioning that assignment 2 will come out this Sunday, but that might be a bit soon to mention that.
All right. So, assignment 2, we're trying to get it out Sunday. Knowing who's involved, we might actually manage that, but it's pretty common, at least when I'm getting assignments out, that they come out a day or two late. There's always things you don't anticipate, but we'll try and have it out Sunday. Certainly it'll be out about that time, so you can sort of pencil into your diary for the weeks ahead. Again, working not look 2 days before the due date and say start the assignment now. Instead, pencil in as soon as you get the assignment, do an hour or two's work, then a day or two later an hour's two work. You've got to do it incrementally on the assignment. There will be, and it will involve a lot of hours, but you've got to spread them out. All right, thank you, Tom, and thank you, Alvin. So let's move to some content for today. Oh, it's the wrong thing. So the first thing we're going to do today is revise characters and strings, and cover some new material. All right, on screen is some code. This is a loop. I'm just trying to refresh my memory. GetChar gets a byte from input. I'd say standard input or Stdin. It gets a byte. Now, in this course, what's that byte going to contain? Almost certainly that byte's going to contain an ASCII code. We don't do anything in this course with anything but input. It's text, ASCII codes. So in that byte will be an ASCII value. This code I've got in Stdin prints out what the ASCII code is, and then prints out how the terminal displays it. All right. Hopefully you've played with code like this. Why am I focusing on this, by the way? This is with this. You want some motivation? This is for this week's lab exercises. So you get to practice this stuff in this week's lab exercises in all sorts of interesting ways, including cracking code. So reading in text, and encrypting it or decrypting it. Following in the great footsteps of Alan Turing. All right, and many others. So what does this code do? In two places, that's not ideal. There are other ways to write this loop, but this is the simplest way. It gets a byte. What's our stopping condition? It's while the value we get is not EOF. So getChar does one of two things. Either it gives you back a value between 0 and 255, which is the contents of the byte, or it gives you a special value, which is almost always -1. You can think of it as -1, but we hash define. well, we don't hash define it. It's hash defined in stdio.h. It returns that special value if it can't get can't read anything. It can't get any input. So this is the loop we'll tend to use in, which is used for maybe all the lab exercises this week, certainly most of the lab exercises this week. This is the pattern for read bytes until I have no more, and here this is an example of do something with the byte. Now I thought I'd do something else here instead of I just modified this to do something else. I hadn't actually really thought about what else we're going to get the code to do. But let me find. So we'll get rid of that, and in here then we'll put something else. So that's the pattern you need for this week's labs. Don't hesitate to cut and paste this. What will I do? Oh, so how about I remove duplicated characters? So if more than one character gets typed in a row, I remove it. Or don't remove it. How do I remove it? Well, not output it. Alright. That's a good idea. So if we see the same character twice, we won't output it. No, I don't want that. You can use printf to output a single byte, or you can use get char's friend put char. There we go. Now I need a last char. How do I make this work? Here's my plan. I'll have a variable called last char which has the last character we read. And up here I'll have an int last char. Alright. And there we go. Is that good code? Well, rather than speculate, let's see what DCC thinks of it. I should have renamed it, but it's still in the same. It's worried about me initializing last char. Good point. Alright, so oh, and I've got this wrong too. Look at line 15. I want to print out a character only if it's different to the last character. That says print out a character if it's the same to the last character. There's a question I want to initialize to. I'll initialize to 0. There. Let's compile and run that and see what that does. And then we might modify it to do what I want. Let's try that out. Oh, so that only puts out characters that are the same as the last character. And it's not putting out the new lines because they're not the, oh, if I put 2 new lines in a row, it puts out them. Weird. Alright. Now my mistake here was a classic one. Is I got reversed the sense there. So what I want to do, that's what I talk about. Don't leave it till afterwards to put comments in your code. If I put that comment on the if statement with an English statement of what the if statement was going to do, I might have seen, and it might have been obvious in my head. Look, line 15 says do this. In English, in the comment, line 15 actually does that, and it would have been obvious then. That can't be right. So we comment as we go with key comments like that, particularly on the start of functions, but also on a key test. So this loop is sort of, I'd call it boilerplate is the word I'd use, standard sort of code that you've used over and over again. Now that's not true for you. It will be, but what's different, what's significant is what I'm doing in here. That's the interesting bit. Let's try that out and see if that's got the, now does it remove repeated characters. Oh, there we go. So we've got a program that outputs characters unless they're the same as the previous character. Now, oh well, there's one thing I wanted to recover is, yeah, when we're reading from a terminal, we could type any number of characters. There's no limit to the number of characters we could type. So we need to have some special way of saying, no more characters for this program. That special way is on a Unix-like system, which includes your Mac, is Control D. So I just type Control D. That signals no more characters to come, and when getChar tries to get one, it won't be able to, so it'll pass back the special value EOF to my program saying, sorry, I couldn't read any more characters. So you'll need to use that in this week's lab. Up here, I stopped the whole program by just typing Control C, which also works, but is, yeah, you're just terminating the program. And DCC is put code in there to tell you where it was when you terminate with Control C, because it thinks you've terminated the program with Control C, something's got wrong, you must need debugging information. One thing to note here, by the way, when we terminated the program, you can see the ASCII codes in the variables. So we don't ever need put ASCII codes in our program, we don't need to do that, but we might need in debugging to look at ASCII codes and figure out ASCII codes. So I might need to figure out that 10 is the ASCII code per new line if I'm trying to debug my program to understand how it's going wrong and exactly what it's doing. Right. What about a what's true here comment at line 15, Ben says. What is true at line 15? Well, Ben, what comment would you put there? So I think Ben has been to the lecture that Carol Morgan gave about introducing assertions effectively into your program, post conditions and preconditions. Yeah, nice thought. I'll leave that for Ben to think about, but yeah, exactly the sort of thing you should be thinking about. Alright, so that was characters. You'll get to practice all of that in the labs, and I think the notion of characters won't give you particular issues in this week's lab, but the lab itself has all sorts of interesting exercises there. Okay. Let's move to our second thing we want to look at, which is change. Oh, alright. So note here, this is main for weeks 1 to 5, almost 1 to 4 for the course. We just say main, int main void. Here we have a different definition of main, which has just give me a second here. Alright, I'm back again. Alright, so we can declare main in a different way, like this. And that gives us access to command line arguments. So what are command line arguments? These are actually command line arguments for DCC. So DCC is just another program, but so it's given 3 words on the command line to tell it what to do. Now, you're not going to be writing DCC, but you can write programs that work with command line arguments. You can write programs that get what they're supposed to do, their inputs if you like, from the command line. So, oh, that one says print command line arguments, but it's actually summing them. It's actually the same as this one. Yeah, they're both doing the same thing. All right, that doesn't matter. So here's a classic program that does something with every command line argument. We get told how many command line arguments we've got. There's a trick there we'll come to, and we get them given them as, well, you'll say that's an array of pointers. Yeah, it's not much different to an array of arrays, but it's really an array of pointers. That is true. And we go through them. Now, the first in element 0 of this array is the program name, and we don't normally do anything with it. The only thing you do with a program name is if you want to give out a better error message, you'd include the program, use that to include the program name in a better error message. But from elements 1 on in the array are any words that were put on the command line. So if we run the program and put a word here, it's available as element 1 of this array. So this is a classic loop that goes through each command line argument. Now that loop may execute 0 times. If there are no command line arguments, argc will be 1 because the array just contains the program name, and this loop starts with I1, so it never executes its body. But for every command line argument, if there are any, this loop executes once. There is the command line argument. Now, the command line argument is an array of ASCII codes. We use a library function, A2I. There's several library functions that we'll cover in future weeks. But it's a simple one that says, here's an array of ASCII codes. They contain the ASCII codes for digits converted into a decimal integer. And that's n there. We add it to our sum, and this sums up the command line arguments. We'll actually try that out. That's pretty easy to try out. I think we left that over in another directory. Yes, we did. Oh, and there's a bit of a random bit of text has crept into our program. Let me save that. And we can run it. So we can put in 5, 6, 7, and it prints out their sum. Lovely. Given no command line arguments, it says their total is 0. What does it do if... Right, A2I is a very simple function. It does no error checking. So apparently I've asked convert hello to an integer, and it said 0. That's not ideal for serious programming, and if you look in the lecture slides, we recommend another function if you want to do serious programming. Don't get too fussed about that. You know, for the exam, we give you access to the names of all the functions, and so you don't have to memorize these things. And you also when you're programming, you look up these things. So, but just it's sort of a more general piece of knowledge. We can use A2I for that, but it's a very simple function. There's no error checking. So that's command line arguments. So then we went to work on a more complicated program involving command line arguments. So it went to tell me whether two command line arguments rhymed or not. And I've got it here. We're going to make it a bit more complicated in the first part of this lecture. So we've got one we call simple rhyme. Alright. Oh, and this is such classic code. So it's very common if we're taking inputs from command line arguments to want a certain number. We might want 2, we might want 5, we might want 1. Cleverer programs might handle different numbers of command line arguments. They might work with 2 or 3 or 4, but it's very common to write pretty simple programs that just need to have a certain number of command line arguments. And the first thing you should do as a careful programmer is check that you've got the right number of command line arguments. So this is just such a check that's saying, have I got 2 command line arguments? argc is 3 if you've got 2 command line arguments, because there's the program name and the 2 arguments. And we can even try to, I've compiled that program. So if I give it no command line arguments, I'll get the message. If I give it 5 command line arguments, it'll complain. All right. And what does this do? It tells me if 2 words rhyme. Okay, what words rhyme? Cat and bat rhyme. Rhyming score of 2. All right. Now, this is not meant to be an exercise in applied linguistics. There are actually ways to write clever programs that work out if 2 words rhyme. We're more interested in simple manipulation of characters. So yeah, what does this program done to convert the rhyming score? Well, we can work top down here. There's a function called rhyming count, and we pass command line argument 1 and command line argument 2 to it. It returns an int, and we print it out. So that's the top-down view. So we can then dive into the function and look at that. This is not the most pretty program. It's been done in a bit of a rush in a lecture, but it's got the crucial thing here of, here's the function. It starts out telling me what it does, which is count how many places they have the same letter in the same place in both words. How long is this array? How long is this array? We don't know. Command line arguments could be 1 letter, could be 10, could be 50, could be 10,000. We don't know. And there's a problem in C. There's a general problem in C. When an array is passed to a function, there's no way built into C, there's no way part of C to say what's the length of this array. If you've done a bit of coding in another language, you might have been in a language where that's possible. There are some languages where it's possible, some languages where it's not possible. C is one of the languages where it's not possible. There's no way to say, oh, I've got an array, how big it is. Now, you might be able to, if you can go elsewhere in the program and see where the array came from, maybe you know how big it is. In this case, with a command line argument, we don't. What really happens is we're passed a pointer to the array. Passed a pointer to the first element of the array, more precisely. Right. Yeah, it's a subtle thing. It's really, there's a world of complexity here which you don't need to understand in this course. Then we need a way of knowing the array length. So we've talked about these 3 strategies. One is the one we used in assignment 1, where the array passed to the function was always the same size, and that size was hash defined. So it's a constant, it's fixed. We always pass an array of 10, an array of 20. In the assignment, what was it? Was it a 10 by 10 array? I can't remember what the minefield was. Second strategy is pass the array length as an extra parameter. So to add in a parameter here to say word 1 is 5 long, add something there to say word 1 and 2 is 10 long. We can't do that here because we don't know. Well, we could, we could, but we'd have to figure that out. Now, C strings use strategy number 3, which is to put in the array an extra special value to say you've finished the array. That extra special value is 0, and you'll often see it. It's perhaps better written in a different way when we're dealing with this, but that's exactly the same. You'll see a lot of code that writes it like that, and that's clearer in the sense that I'm dealing with ASCII values. It sort of implies I'm dealing with ASCII values, and so that says word I contains an ASCII value, and it has to be not equal to the special value 0 at the end of the array. Word 2i contains an ASCII value, and it has to be not equal to the special value 0 that marks the end of its array. That now gives us a loop that executes down the array, stopping if it reaches the end of either word. That was my bug in the last code, wasn't it? So this loop executes while it hasn't reached the end of either word. So it checks out element 0 of either array, element 1 of either array, element 2 of either array, until it gets to the end. Alright, so I want to do better rhyming. Rather than just compare letters in the same position, if for example we have an E there in hello and an E somewhere else in Andrew, I'd like to count that as part of my rhyming score. Yeah, again, please don't worry about whether this is good linguistics. It's meant to be a programming problem, so it's a thinly, the justification here is thinly, but it's thin, but still I want to calculate a rhyming score for if a letter occurs anywhere in the word. Now, you might dive into a nested loop here, but a better thing is to write a function, an extra function. What do we call it? Letter is anywhere in word. Letter. How about that for my function? If I write a function that returns 1 if a letter is anywhere in a word and 0 otherwise, and then I can use that. So that's my plan. That's what we're aiming for in this coding, is to come up and be able to think about ideas like this. I can write this as a function and then use that as a building block. It's hard. It's really hard because you don't have this instinctive knowledge of what you can write as a function yet. But hopefully it's developing. All right, let's put you down here. So how would we, and now, what have I said? Put a comment here. What this function? In Word, so before you write the function, try to put a statement there. What else? What's another tip here? Examples aren't bad, actually. Spell things properly would be a good idea. Yes. You won't find the tutors too harsh on spelling mistakes, because many students have the excuse of English as, you know, the second or third language. Not my excuse, of course, but it is better to spell things. I guess we can use spell checkers, can't we? All right. So we could say, give an example. It's not very good, is it? Because that equals is not really true. E.g., if so we just put it in English. And another one as well. Alright, that's not a bad comment, written quickly. How do we implement it though? Alright, so we've got to go through every element of Word potentially. So we can go through, what's a loop that does that? I equals 0 while, we'll use an I++. Remember, I++ is the same as I equals I plus 1. Now, the stopping condition. So the stopping condition is we get to an element of word that contains the special value. So it's probably, we can write it like that. There are a few ways to write it, but that's probably the best way to write it. So that'll go through every word, every array element in Word. So we can compare the ASCII codes and say that if word equals letter, we've found the letter, so we can return 1. If the loop exits, we can return 0. Oh, and this is a particularly beautiful function. You'll see this in many forms, but this is everything coming together and working nicely. When you can write functions like this, the world is a good place. Things are fitting together nicely for you. So here's the body of my loop. The main task is I compare that array element to letter, and if we found it, we return 1. That's our job, is return 1 if the letter occurs in the word. If we get to the end of the word and never seen letter, we return 0. We could even put a comment to that effect. About that. So I'd say this comment, hugely important. Get that right. Now, down here, comments inside the function, less important. If there's something subtle, there's something clever, there's something a reader won't understand, sure. And that's a negative comment. That's making the world a worse place. It's unneeded. It just adds text and messes up your program. All right, that's not bad. And now for my, I could just change this. I will delete this. Yeah, this is the problem with comments. You've got to be careful. If the code changes, the comments got to change as well. That's why programmers love making names good and reducing the need for comments, because then if the code changes, you don't have to change a corresponding comment. So I guess you've got to make sure you've got to change the name. All right. Letter is anywhere in Word. Word 1 I, word 2. And my stopping condition, I just need to go through the letters in word 1 now. So my rhyming score is accounting how many times any letter in word 1 occurs in word 2. Now, there is an issue, by the way. There's an asymmetry there, which is less than an exercise for you to fix, and fixing it without double counting is also interesting. Then, but yeah, what I'm talking about is if you swap words 1 and word 2, you'll get a different rhyming score, which is probably not what we want to see. The true mathematicians among you will be appalled by that, but I'll leave it as an exercise to you to fix the code. You have to make the code a little more complex to do that. All right, but that's a nice, showing you a nice piece of adding some code to it to do a more complicated calculation with the 2 command line arguments. I've called this rhyme.c, haven't I? So let's see if it actually compiles first. Come on. So sad. What did I get wrong? A missing bracket. Lovely. Alright, let's try it out. Cat and dog should be 0. Cat and act, that should be a score of 3. Oh, look at that. Works first time. Let's try Andrew and hello. Score of 1, isn't it? Yeah. Alright, so that's scoring 1 because there's an E there and an E there. It's scoring 3 because C's there, A's there, T's there. It's again, it's as I said, it's poor linguistics. It's not. It's a worse way of anything to measure rhyming, but it's a more interesting programming pattern. So our notional rhyming score is letters occurring anywhere, and we've done that with a beautiful function here. So you can read that as at your leisure and figure that out. All right. All right. Oh, there's a comment. Aldous has a comment. Do we need a stopping condition to make this loop not run necessarily? Now, actually, this loop is actually efficient. That says as soon as it finds the letter, the function stops executing and returns. So there are other ways to write this that wouldn't do that, but that loop terminates. The return, yeah, it's a good question, really a good thought. What does a return do in a function? Yeah, it's got 2 jobs. Return has 2 jobs. One is stop the function executing. That says you're done, go back to whoever called you. And remember, a function could be called from 50 places in the program. We're writing little programs, often it's called from 1 or 2 places, but it could be called from many places. So a return says stop your execution immediately and go back to where you're called, which in this case is here. And its second job is to say what value you're passing back, and that's it's saying it's passing back a 1. There are special void functions that don't pass any value back, and you don't have to put anything there. Every other function a return has to say what value you're sending back. So that return stops the loop, stops everything, stops the if statement, nothing happens in the function after that return. It all goes straight back to here. This is a program, by the way, to understand everything of. Sometimes we say, don't worry about little bits here or there. And you can understand everything in this program. Right. Okay. I think that's where oh, no, I've got one more thing I want to do to this. All right. Let me go back to lecture slides. There was something we didn't get a chance to really talk about in any length. All right. You could do everything with getchar. Read byte at a time. Do something with the ASCII code. There's a lot of coding, an awful lot of coding, where what you really want to deal with as what you want to handle, what you want to look after, is a whole line of ASCII codes. You'd prefer to be given an array containing the ASCII codes for a whole line, because you need that whole line to do anything in your program. There are a few functions in the C library that help you with that, but the classic one, the one you'll use, not in this week's lab, is Fgets. It takes 3 arguments. The third argument you won't do. You'll just put Stdin there. It's where Fgets should get its characters from. First argument is an array where it's going to put the bytes, the ASCII codes. And then the second argument is the size of the array. It won't overflow the array. It always puts a terminating 0 character in the array. Sorry, terminating \0. It does store a \n in the array if it reads an entire line. We really need to test it out, don't we? Let's try out Fgets. What I wanted to do is to convert the rhyming function to work with instead of working with command line arguments, to read a line of input from standard input. And I'll show you the difference. So where it got the two words it was looking at, to get them in a different way, just to show you the comparison. But it's better, I've said this a few times, you see students they're trying to do something in an assignment and they've got quite a bit of code, or even sometimes a more complicated lab exercise, and they're getting confused by many things, and they'd be better off trying to test something in isolation. So we're trying to figure out how to use Fgets rather than start by putting it in complicated program here we've written, rhyme.c. Let's write a tiny program using Fgets and see if it works. Now, Fgets gives us an array of ASCII codes and puts a 0 on the end to mark the finish. Printf %s can be used to be output an array of ASCII codes with a 0 on the end. So we can use printf there. And we better put a message here to say enter a line. So let's try out Fgets. So let's try it out. There we go. Let's see if we can successfully call Fgets. Spelling's not very good, but that'll do. Right. We're seeing another thing I just mentioned, but it's writing on a new line and another new line. So Fgets reads the new line in. So in this array, we can print it out, can't we? Let's try. Let's print out the contents of the array rather than using printf. Let's go through the array. We have the power. We know how to do this now. We can print it out. So that's our loop to run down the array. That's not good. We'll do something unfortunate. And watch this. We'll write out what the ith array element is. We can write out the array Fgets has given us back. So a little bit of experimental code to see what Fgets does. Here's my line, hello Andrew. And there, look at that. That's all the ASCII codes spilling out. And as I've said, we don't put them in our programs. It's helpful if we can figure them out. And there's one we know about. 10 is new line. So we can see the new line in the array. If we do some counting and some figuring, we can make some guesses. I'm guessing here 32 is space and 65 is capital A. But it doesn't really matter. The crucial thing, by the way, is one we haven't printed out. This element at index 13 contains 0. We didn't print out. Well, notice we stopped here when we got to element 13. And the new line was put in to the second last element. Anyway, that's Fgets playing with it and then dumping the array to look at it. But typically we don't dump the array, instead we pass it to other things. Can I make my rhyme function, my rhyme program, switch?
Andrew, before we move on, I think Justin had a good question on what is Stdin.
Oh, thank you for the question, Justin. Stdin. All right. So it's actually the technical term is it's a stream of bytes. Now, we don't talk about this in this course because we're focusing on programming. We don't want to get into what these byte streams are and other byte streams. But a C programmer can actually deal with many streams of bytes. It could actually deal with a stream of bytes coming from a file, coming from a network, coming from a device. There are other possibilities which we don't have to get into. So it's a good question because every Fgets we do in this course will have Stdin there. It's the only place we'll take bytes for Fgets in this course. But there are many other possibilities when you get to other C programming. Why aren't we playing with us? Well, actually, they're not really interesting us. We're interested in writing this sort of code here to understand how to write the loops. So that's what we're trying to learn at the moment. In later courses, we'll get into that stuff. But excellent question. So that's always going to be Stdin for the things you write. So it's array, size of array, and then Stdin. Oh, there's something really, yeah, something glaring occurs to me. There's a magic number here, and a magic number there, and a deficit in Andrew style mark. All right, so programmers hate this because if this changes here, then that could be wrong. And you're saying, well, it's not that hard, just change every 256. Yeah, all right, so in a tiny program like this, that's okay, but in a complicated program, 256 could appear as a magic number for 5 different reasons, and then you've got to figure out which of them are associated with line length, and which are another thing, and which are another thing again. So it gets really scary. So I really should do something like this, and hash define a value. There. All right. So that's nice, I think. All right, so let's copy this code. Let's copy all of this code over into our other program and see what we can do with it. We'll go to rhyme.c. Yeah, we've got to change this. So we'll copy you in here. No, not like that. Like that, maybe. Alright. So we want a hash define up here. A line. Alright. Oh, we want. But let me start now into changing this program. While I think of it, I'll rename. Save as rhyme Fgets. There we go. Alright. So this is one form of the program. It's saying get my words as command line arguments. Otherwise, I don't need that this time. I'm going to get my words from Stdin, from standard input. So then I don't need to do this either. I'm not sure max line length is the right name for the thing. It should be max word length. Alright. Here's a tip to make your future life happier. If you have to choose a constant, a maximum, if you have to put a limit on things, programmers prefer not to put limits on things when they can, because they don't want things to break because the limit is reached. If you have to, make it larger, unless there's a cost. Make it much, make it 4 times, 10 times bigger than you need. Those of you who are, mechanical engineers might be familiar with, when the people are building bridges, they figure out how big the girder should be, and then they add a significant safety margin to it. Our costs are much lower here, so we can. If I think maximum word is going to be 64 characters, I might make that 2048. Yeah, you're saying, what happens if that limit's exceeded? Yeah, we won't get into that. today. You get back, well, you get back part of the line if the limit's exceeded. The effects on your program then, handling that in your program, get quite complicated. Enter word 1, enter a word 1. So, and I've said try to avoid using the same word twice, same variables twice in your program until you're confident. It's not poor programming style to reuse variables between functions. Each function is its separate world, and if it's the same concept in two different functions, it's quite sensible to reuse the same variable between functions. It's just, I find, as people are learning to code in their first weeks of coding, they get less confused if they don't reuse variable names, even where it's quite sensible to do. So I've called that first word. You're saying, you're copying code. Could you put this in a function? Yes, I could, but we won't for now. Yeah, every time you cut and paste code, you should be asking yourself, oh, well, that could be a function, and I could just be calling it twice, couldn't I? So let's put a white space there. Second word. Second word. If I've right, if I've got this right, and there we go. We've got code to compute our rhyming score for two words, and they're coming from a different place. So remember what we saw up here? Word 1 and the words were put on the command line. Now we're going to supply them on standard input. If my program compiles. If. Oh, so close, so close. Oh, alright, so this is max word length. Now, if I was a smart person, I'd use gedit substitute probably to fix that. Or I would have got tab completion to maybe to... Yeah, so as you become proficient with editors, and I'm not proficient with gedit because I don't normally use it, you should try and develop the skills for these frequently used coding operations. You should take a little bit of time to find out, how do I quickly do this or that? And if you want to start fights, which you don't, of course, you ask people which is the best editor, or ask two tutors which is the best editor. All right, programmers disagree a lot about what editors are good and what editors aren't, which we should keep civil and friendly and acknowledge is a personal and relative decision. All right, have I got this right? Will it get my words from standard input? All right. So far, so good. Oh no, no. 2. That's a bit weird. Let me try on the other one. 4. 4. What's going wrong? Alright, you smart people in the chat, what is going wrong? Yeah, there's a question is, what size here? Yeah. You wouldn't necessarily make it gigantic. And you're saying, well, wait, how do I know what's gigantic? How do I know the costs of this? You don't. But we've got some wonderful courses if you're in a computing degree that'll you'll understand all the costs and benefits and things like paging and so on. But I will say beginner programmers are much more likely to make this 16 rather than something like that, which is much less likely to cause you issues. Don't make it 2 million though. Alright. Okay. What is going wrong? Oh, I can see Barry and Max in the chat. Have the answers. Yes. What is the common character? There was a clue. There was a clue way back here. Oh, we can do it again, can't we? So we'll run the test Fgets. I'll put in ZZZ. And I'll put in Y. Oh, well, I can put in Y if I like, but you're already seeing, isn't it? There is a common character there, isn't there? It's the new line, the 10, that's there in both arrays. What do I do about it? Alright, you'll often hear in coding people talk about hacker's solution. Hackers is a word that gets heavily overused, so you're never quite sure what it means. Hacker can mean someone who's engaged in breaking into systems either for good or for bad. It can mean someone who's quite clever at coding, but people will talk about a hack and they may mean something is impressive but they may also sort of talk about a solution as being hacky, as being not a good solution, solving the problem but not in a good way. So I'll show you a way to solve the problem not in a good way. You're saying, what does that all mean? Yeah, it just leaves you confused about what hacker means, doesn't it? Probably a word best avoided then if it doesn't have a clear meaning. Here's the not good solution to this. We know there's a new line. If we assume, that we don't know there's a new line in the first word, so we assume there's a new line in the first word, and then we just reduce the score by 1 because we assume we're counting a new line. Oops, that's not the program I wanted. We need to take a break. I've been talking for more than an hour, so we need to take a break. You can think about better solutions. If I've got time, I'll see if I can think of anything a better solution than just assuming there's a new line in both words and subtracting 1 from a count as a consequence. So, all right. Let's go to a 5-minute break, and if there are got any questions, you can ask them in the chat afterwards. But otherwise, let's stand up, have a look at the nice day outside, think about where you're going to go for your allowed exercise, and assuming you're not outside the lockdown area in Sydney, and come back in 5 minutes. All right, everyone. Let's come back. So my problem was, we saw the new line being counted. So we had a suggestion in the chat that we try and avoid counting new lines. And we could do that. How could we do that? Well, I could do it like this. I could say if it's not a new line, something like this. Yeah, formatting these big if statements gets to be messy, but that's a possibility to write it like that. So that would be one thing, to, in a rhyming count, to only check for new line. Oh, word 1. Word I. So that's a possibility. That should work nicely. So put an explicit there, check to say not new line. Notice, by the way, there's a phase every sort of programmer goes through. They get ASCII and I think, that's word I will just contain an ASCII code, so I can say word I not equal to 10. It's fantastic you've realized that, but the next thing you should realize is it's better written like that. Think of that as a hash define for the ASCII code for new line, hash defining it as 10 if you like. It's so much easier to read. Alright, so that's one possibility. Now, I think, yeah, in the stream, Jaden is suggesting, well, shouldn't you test if it's a letter? You want to do rhyming, rhyming's about letters, shouldn't you do a check if it's letters? And we did mention there are some C functions that do that in Ctype.h. Can I go man Ctype? I can go man to Ctype. And there are functions predefined for it saying, is it a letter? We could write those ourselves as well, so but I could say if is at a letter, and that would be better. So that would be a better way of doing it. Yeah, so nice suggestion, Jaden. I would also have to put the hash include ctype.h at the top, so I'd have to add that line to use that is alpha. But that's really a better way to do it in general. A lot of coding that you've got this choice. Do I do it in a positive way or a negative way? And which is best depends on the circumstances. I think this is probably best for our rhyming purposes. Let me show you another way. A more interesting way, but perhaps not a better one. So Jaden's idea here is the best probably, but I'm going to dump it for now. And but back here, I've got an idea. I'm going to change first word. This is my plan. So I'm not. This is. We're doing this for the interest, not necessarily it's the best solution. So I like Jaden's idea of checking further down in the code for letters. But here I'm running through the elements of first word. So I equals 0, I equals I plus 1, while first word I not equal to 0. Actually, yeah, and probably a better way to write that is like that, but it's the same. If I find a new line, I'm saying change it to an exclamation mark. Right. So that's my plan, and then I'm thinking that will fix the problem. So let's compile. Oh, let's save and compile. This time for sure. Yay! So the exclamation mark, the new line there got changed to exclamation mark. That breaks if we actually put an exclamation mark in the other word. So what can we use other than exclamation mark? Let me show you trick number 2. What happens if I change the new line to be a 0? Then any code following that executes down the array, stopping and when it gets to a 0, will now stop at this element. So it will stop where the new line was and won't go any further. And that's what we want. So what does that do in effect? It deletes the new line in a weird way, but it deletes the new line. In fact, this is a common thing to want to do. You might put this in a function to say, to overwrite the new line with a 0, so that any code looking at this array now stops where the new line was. Yeah, people are saying, what's this back? Yeah, it's a bit complicated, isn't it? It's a special way of writing just a 0. But it's so single quotes give me the ASCII code. So it says, give me the ASCII code for the special value that comes out as 0. I don't mind actually writing it like that, but you'll certainly, I know you look at resources on the internet and you'll see lots of coders writing it the other way, but they're equivalent. So
I guess for consistency, I'd say to keep it as \0.
Here. You see, and I get this. This is it. Not only is Alvin saying it consistently, but I consistently hear this from tutors. Tutors really like writing it like that. I don't mind so much myself, and you'll find that's a difference in attitude often between programmers, and particularly programmers who've been programming through all sorts of languages and like me are used to so many things and don't worry so much about consistency. But consistency is a good thing. So all right. So because we're consistently we're dealing with ASCII codes in first word, so we want to say this is an ASCII code. It happens to be 0, but that's how we write it. It does give you an extra signal that this contains an ASCII code that my version didn't. All right. So we'll leave it as that. All right. Okay. Don't worry too much about that. All right. Also, don't worry too much about this. So this was an extra. If you understand this code, fantastic. If you don't panic. But how to use Fgets. Fgets, this was the main message here, was using Fgets. So the main message was, how do I make this? And look here, no command line arguments. Instead, I'm putting the words here. So we've seen 2 versions of the function. One is rhyme, we've called. And I actually haven't got both of these up on the class website yet. Rhyme, which takes, we'll put in Alvin, and does Alvin rhyme with dolphin? Rhyming score is 3. And a different version of the function, which reads the words from standard input. I'm going to put in Alvin and dolphin. Dolphin. So 2 different ways of programming. Yeah, so they're not on the class website yet. They will be, but they are linked in the announcement for the lecture. There's a link to where the live coding location. So they're both there already. Okay. Sadly, I could talk for so much longer about this sort of programming, but sadly I don't have time because we've got 2 more things to cover which lead into next week's lab exercise and lead into the assignment. So we're on a mission here to cover a few things to get us in a there's a key sort of set of concepts that we practice in starting with next week's lab and then the week after's lab and the assignment. So we've got to remember where we're going. Alright, I have a program to show you to set the scene. A program I prepared earlier. So let me pull it up on screen. It's a program that people often try to write when they start C programming. So I've written, admire the function I've tried to write here. it's meant to create an array of 5 ints. I've initialized it to the first 5 primes, and it's saying I'll give back to whoever calls me this array. So this function, its job will be create array. Takes no inputs, which we write in that weird way of just putting void there for a function that takes no inputs, and it's going to give back that, and that's a valid type. I can say here's the name of array, and that will work. That will give back the array. So it gives me back a pointer effectively to the first element array, and this is valid here. This will work as well. So I can create the array with a pointer there and print it out. There's a huge conceptual problem. So there's not a sort of simple types. You've got mismatched your types or things like this. This code sort of makes sense, but it has a major conceptual problem. Now, the conceptual problem is so big that the compiler tries to spot it when it compiles your program. It's such a big and important conceptual problem that the compiler will pick it up, but it's not in the small details of the program. So DCC, I think, yes, it gives me a warning only. Now remember again, warning. Yeah, if you're like me or Albin and been programmed for quite a while and understand a lot, warnings, maybe we could ignore a warning, maybe. Probably not, but maybe. If you've been programming for 6 weeks, warning means error, stop, broken, something's wrong here, try to understand it. Oh, we've even got a link here. It's saying go to this URL and it'll explain what's happening here. Quality error message, DCC. Because in this, so what is happening here? Primes will not exist after the function returns. What's it talking about? So here's my variable inside the function, and I'm returning a pointer to it. DCC is saying a major problem. Let me give you a graphical explanation of what DCC is talking about now. So we start off, main is called, and it's got variables inside main. Okay. Main then calls another function like create array, and they get variables created inside them. All of this happens on the stack, for what it's worth, but you'll hear that a lot. But the important thing is these variables get created by the function that's called by main over here. Now, when the function ends executing, all the variables inside it are destroyed. And then we're back inside main, and the variables inside this function no longer exist. Yeah, so this is my example here. I'm returning a pointer here, and the pointer points at this variable, but this variable no longer exists. And then here I'm trying to use the pointer. It's incredibly dangerous. All sorts of nasty consequences occur from this. This is one of the fairly frequent causes of either software bugs, nasty software bugs, hard to find software bugs, subtle software bugs, bugs that persist in systems for long times, causing people problems, and it's a big source of security holes. If I try and run the program, I think DCC will pick it up, but pick it up in a weird way. It's even hard for DCC to get right. It's saying, oh, that's not initialized. Yeah, so this is bad. So we need to look at what we can do that's different, what we can do that's better. Is there a way to write this sort of function that returns a variable, returns an array, returns something else that isn't destroyed because the function has exited? It was that backslash shouldn't be there. I cleaned up these slides, I honestly did, but I missed one. Alright, built into C is a function called Malloc, short for memory allocation, Malloc. You give it just one argument, which is the number of bytes you want. It returns a pointer to a block of memory that size. What we do with that block of memory is up to us as programmers. It doesn't get automatically cleaned up, automatically removed, if you like, when a function ends. So a function can use Malloc to get a block of memory and then do with it what it likes. So the function could return that. It's up to the programmer when the memory gets cleaned up, and Malloc has a corresponding friend, free, which you use to say, I'm finished with the block of memory Malloc gave me. And for every piece of memory you allocate with Malloc, later in your program you should call free to say, I'm done with that memory. So for every Malloc call, effectively there has to be a corresponding call to free occur somewhere in your program. It's a challenge. It's a real challenge. Oh, I'm very sad. Malloc. What Malloc bytes does. So what it allows us to do is we can have our function. It can call Malloc. The function can return. The memory allocated with Malloc still exists, and it can pass back to, say, main, a pointer to that memory. So it gives a function a way of creating something and passing it back. What is the something? Yeah, we're going to see some interesting possibilities over the next few lectures for what the something is. What does free do? You call free to say, I'm done with this, and it says, it cleans it up, it destroys it, it removes it. What does it really do in a free? We actually probably are covered in COMP1511. It's a classic computer science exercise to get a student to implement Malloc and free. So maybe it gets done in COMP2521. After the exams, if you really want to know, you get Google, because it's a classic teaching exercise for a second, third, fourth computer science course. You'll find plenty on the web about what Malloc and free actually do. It's really interesting and clever, but sadly we can't get into it. Here's a word here's a term you might have seen before if you've been reading about computing, but now you get to know exactly what it means. A memory leak. A memory leak is a term for where memory is allocated with Malloc and not freed. If you have a long-running program and it's got loops in it, and inside those loops memory is being allocated with Malloc and it's never being freed, then the memory leaks become a major issue. You don't write long-running programs in this course. We don't write programs that run for days or weeks, but we have to learn to code for programs that do this. If you go on to be a C coder, you may well be writing exactly that sort of program. Lots of real programs are long running, and memory leaks would be a major issue for them. So DCC has a special option to check for memory leaks. Don't worry about it now. We'll tell you to use it in week 8, I think, or to check for memory leaks. Autotest will use it as well to test. It checks to see if for every call to Malloc, a call to free has been made to deallocate the memory. Oh, all right. Malloc has an important friend, which is Sizeof. Sizeof tells us how many bytes anything will take. So I want to know how many bytes I need for a single int. I can say size of brackets and a type, in this case int, and that will tell me how many bytes are needed for an int. Saying, Andrew, you really should write a test program. Yes, I guess I should. Alright, let's write a test program to test out size of. Where was my test Fgets program? Yeah, alright. Let me write a test size of program. What am I going to do in this? First I'm going to change the name so I don't forget. Test size of. It's a really small program. Really. Yeah, this is encourage you to write tiny programs to test ideas. So I want to test out what Sizeof does. So I'm saying Sizeof, tell me how many bytes I need if I want to store a single integer. There we go. All right. And I've got it. And I've got to spell printf properly. Oh, that's sad. Yeah, Sizeof, for complicated reasons, doesn't return an int. So if I want to print it out, I can do it like that. Don't worry about that. Nice of the compiler to tell me what printf format I needed. But there we go. Size of an int is 4 bytes. So I want to store an int, it's 4 bytes. Oh, I want to store an array of ints. If I want to store an array of ints, it's however many elements in the array multiplied by the size of one array element. C guarantees that for me. It says if you want to, you can store an array of n things in n times the space to store one thing. I don't leave any bytes free in the middle of arrays or anything like that, C says. So if I want to store 1,000,000 ints, I can do that just like that. You think, can you do that? Can you really do? Yes, you can. Storing 1,000,000 ints is no big deal on a general purpose computer. On this computer, storing 1,000,000,000 ints is no big deal. You probably couldn't do it on the sort of with the limits we set on our CSE login servers and VLab, but on this machine, my own machine, I could certainly create an array of 1,000,000,000 ints. But 1,000,000 ints, 10 to the 6 ints, that's easy. So that code, that's all fine. So that's using Malloc. Now, every call you do to Malloc in this course should have a size of in it. You should never have a simple number in it. It should always be use size of to work out how many bytes. You're saying, I know. Yeah, you probably don't know how many bytes you need. So you don't know that the int is 4 bytes, for example, and this code is, because it could be a different number on potentially, and it makes the code much more readable anyway if you're going to use size of. It's saying I'm allocating a size. I can read that and say 1,000,000 times the size of one int. I'm allocating a space for 1,000,000 ints, and it's creating an array of 1,000,000 ints. All right. The relationship between arrays and pointers is a subtle and complex thing, which even your tutors will struggle with. But yes, there's a very close relationship with arrays and pointers, yes. So what Albrado is pointing out in the chat, I think, is I've got a pointer here, but it looks like I'm just treating it as an array. Yes, you can do that. So arrays and the pointer to a first element array are very similar things. And when you pass an array to a function, what actually gets passed is a pointer to the first element of the array. Some people will tell you that they're exactly the same, and for the purposes of COMP1511, that's almost true. Alright. Can I fix my broken program that tried to create an array? Yes I can. So that was called create array. Alright, so we had a huge fail here because I tried to return that as which is a pointer to that, and it failed. Can create an array that will hold 5 ints like that. I can try that. Actually, we'll make it primes pointer. That would be better. Now you might think that would work. That's completely broken, by the way. DCC is going to say, Andrew, don't even think of trying to do that. Alright, you can't initialize anything but an array as you declare it. You can't initialize Malloc space using curly braces. You just can't use curly braces like that. So I'm stuck with a painful initialization. I'll initialize the first and the last, and I won't bother with the ones in the middle. What is it? Oh, come on, VLab. Okay. You are calling the function malloc on line 12, but DCC does not wrap malloc as a function because you have forgotten to include stdlib.h. Thank you, DCC. I have indeed. It does seem a bit stupid, doesn't it? If you can figure out that's where it's coming from. But that's what we live with. All right. No, that's not quite good enough. That's not quite good enough. What have I forgotten here? It seems to be working. I've created an array of 5 elements there. I've returned it from the function. I've been lazy. I've only initialized the first and the last element there. There should be 3 more lines there. I've got out of the function and confirmed I've got an array back by printing out the 4th element, which contains 11. Yay! What's wrong? Well, let's see if dc-lead check will do its job. We'll ask DCC to check for memory leaks. Oh, look at that. function error free not called for memory allocated with malloc in function create at line 13. So DCC is saying there's a piece of memory that was created, that was allocated with malloc there, which was never freed, which is a pretty easy bet because there's no calls to free in my program. Yes, malloc is short for memory allocation. It's a contraction. You're saying, wouldn't it be less confusing if it was called memory underscore allocation or memory allocate? Yeah, maybe. So this is, given somewhere, it's set aside 20 bytes of memory and given me back a pointer to it. And the great beauty of this 20 bytes of memory is, even though the function returns is, it's that memory is intact. It gives me control of when memory comes and goes. But I've forgotten to say I'm done with memory. So for every malloc there should be a free. It doesn't have to be in the same function. Often it's not in the same function. So down here I'm saying, oh look, I'm done with the memory pointed to by P. Here I say allocate this, up here I say there. I don't have to say how many bytes are in the block. I just have to say give it the pointer. Malloc tracks how many bytes in the block. Alright, with that free added, program still works, but now there's no memory leak. Now, if you're worried about breaking CSE servers, the operating system in the end cleans up everything, but that's not the point. We're not worried about making the operating system clean stuff up. We're worried about learning how to be a coder who can write useful code that doesn't have memory leaks. So in a lot of circumstances it will matter. In a tiny program like this it doesn't matter really, but we're about learning to write without memory leaks. So our lab exercises will check for memory leaks because we've got to learn to write code without memory leaks. We've got to get in the habit of writing mallocs and frees for when we write real code for real systems where memory leaks matter. So in tiny toy examples like my lecture example, in the end the memory leak doesn't matter, but in real code it will, so we've got to learn to write malloc, and then when we're done with the memory, write free. And this is a really hard problem in programming. How to freeing at the right point, always doing it, never doing it too early, never doing it too late. It's a really tricky problem. Yeah, Jaden's asking, when do those 20 bytes get freed? When the program finishes, the operating system just goes and cleans up absolutely everything associated with the program. And there's all sorts of structures and things in there, which if you do our lovely operating systems course with Kevin in third year, you can understand everything about this, which I highly recommend. But the operating system cleans up all resources associated with the program when it exits. So it will get all the bytes, not just those 20, just everything. So yeah, that's an important point, isn't it? Otherwise, if we had on a system where with CSE, we've got thousands of people learning to code. If we depended on users writing good C code for our systems to keep working, we'd have major problems. So the operating system limits the impacts of any mistakes in your C programs to you. So when you're done, when your program exits, it just cleans up. When you log out, it cleans up other things as well. So the operating system protects the system and other users from any mistakes you make. Doesn't always happen in programming. Sometimes you have to write programs where it's just your C program and the hardware. So if you're working on a tiny embedded system, you're working inside inside a TV or washing machine. So actually, inside a TV, you probably have Linux and Android. Inside a washing machine or a tiny little embedded system, you just have your C program, and you depend much more on what you do. Alright, let's go back to my slides. Oh, it's a different example of... So we've got a nice programming... Oh, actually, no, this is a better one, yeah. Which I don't think I've... Alright, so I haven't got this. I'll just work with this from the slide. So here's a bit more sophisticated example. This one says creates an array of n ints, and this function takes an argument saying how big an array to create and returns a pointer to the first element. It says to Malloc, give me space for n times the size of an int, and then it goes to initialize the whole array to odd numbers. So you can figure that out. It executes from 0 to n minus 1 into the 0th array element. It puts 1 into array element with index 1. It puts 3. So it initializes it to 1, 3, 5, 7, 9, and so on. Yes, the comment here, that would be interesting. All right. So that creates an array, returns a pointer to it, and initializes it to the odd numbers. So this gives you a function that gives you back an array of odd numbers. It's hard to imagine a significant use case for this, but there are not much more. You can put something there slightly more complicated, and you'd have a commonly a useful function. And how do I call this? I call it like that, and then this code prints out what's in the array, and then we free up the array. So that's a more complicated example, a slightly more complicated example. Our function takes n, which is the size of the array to create, and then we get the array back, we do something with it, so we do something which is print it all out, and then we free the memory. Oh, I might have that code. Do I have that code here? Maybe I do. Let's see if we've got it here. We can run it. It's not crucial. No, I don't. All right, that is in the class website anyway, so you can play with that code. All right. I'm going to introduce one more thing today. We've still got a little bit of time, so I'm going to introduce one more thing. As I said, we've got to race through on a mission to cover a few things. The next thing we have to look at. My head's annoying there. I'll put my head right. Alright, a different collective data type. What have we seen so far? So we've seen simple data types, and we've seen int, double, and char, 3 simple data types. Well, I guess void as well. We've seen pointers, which are a way to refer to a data type. They don't let you collect them. The only way we've seen to collect variables together is an array. So I can have 1 int, 5 int, 10 ints, or 3 doubles, 50 doubles, 1,000 doubles, or the same of chars. Or in assignment 1, we actually had arrays of arrays. So that's our only collective data type. There's a thing about arrays. Every array element has to be the same type. Arrays are all of the same type of thing. The word I'd use is homogeneous, which just means the same. So, and that's a limitation, I guess. So, what else can we do here? Another possibility is something that's called a struct, which is short for structure. It doesn't really give the meaning. It's a collective data type like an array. So a struct is n variables put together. 2 big differences with struct. What's put together doesn't have to be the same type. So you can put together an int and a double together in a struct. You can't have an array containing an int and a double. You can put an int and a double together in a struct. So you can have things of different types in a struct. how do we get at the individual elements of an array? We use indexes, index 1, 0, 1 through to n minus 1. Right. Structs, instead, you access with names. So we name the subparts. So each part of a struct is instead of a name. So different types. I'd call this heterogeneous, by the way, but different. So things in a struct can be different. And instead of using indexes, we use names to get at the subpart. What does that look like in coding? Oh, and there again, you're saying, do these mix and match? Can I have an array of structs? Yes, you can. Can I have a struct? Can I put an array inside a struct? Yes. You can even put a struct inside a struct. But they all sort of naturally, that all just naturally works. Now, because structs are more complicated than arrays, we actually have to define them as what they are before we use them. So we separately have to first say what our struct looks like before we create a variable of that type. So here we are trying to create a struct. Every struct type has a name. If you're reading online, people might call it a tag sometimes. So we have to pick a name here for this new type. This, you can think of a custom type of variable if you like. We're saying I'm going to be creating variables of this type, and it's struct bender in this case. In this case, it's got just 3 subparts. Now, one thing you'll notice about arrays, they might be small. They might just have 5 or 10 elements, but it's pretty common to have arrays, hundreds, thousands, millions of elements. So arrays tend to be large. Structs tend to just have a couple of things in them, 2, 5, 10. In this case, we've got 3 things. The third thing is it's easy. It's an int, and its name is power. So it's got a name as a subpart of the struct. If I want to access this part of the struct, I've got to say use the name power. And here we've got 2 arrays sitting inside this struct, which are 2 char arrays, name and element. So there are 3 names. This struct has subparts name, element, and power. The first 2 are char arrays of max length, and the last is an int. We're going to work through an example with this in the start of the next lecture, but don't worry, I think it's worth sort of walking into the ground a little before we come back to start coding with us. Oh, there's a few things here. There's a lot of things here. All right. So that says I want to create a variable of that type, struct bender. So that tells C, go back to wherever I told you what a struct bender looks like. I want to create a variable of that type. Yeah, there's a little bit to read. So this struct is a keyword, like int, for example, built into the language, saying what comes next is going to be the name of the struct type. So I better have said beforehand, told you what that type is. And then you say, oh, I want a variable of that type. And the variable name here is avatar. The key operator here is dot. What square brackets are for an array, dot is for a struct. So square brackets are what are used to get at the elements of an array. Dot is what I get used to get you at the subparts of a struct. The word that's most commonly used for the subparts of a struct is fields. So you probably refer to the fields of a struct. So this says dot. On the left-hand side of dot should be a struct, a variable of type struct. On the right-hand side should be the name for one of its fields. So that's a dot in use. So it's a two-part problem. So if we're saying, is avatar a variable of type struct? Yes, it is. It's struct bender. So power better be one of the fields of bender. And we go back and do power. You want to think of this as in memory. Let's suppose max length is 16. That might be 16 bytes. That might be 16 bytes. That might be 4 bytes. So that whole thing will take 36 bytes to store. So you can imagine that C sees this declaration of avatar of struct bender and says, oh, I've got to set aside 36 bytes. I've got to set aside somewhere to store the name, the element, and the power. So the equivalent to this would be, if avatar was an array, we might be saying avatar 2 equals 10. But arrays, we use square brackets and numbers to get at the subparts. Structs, we use dots and names to get at the subparts. Here's also using dot and name to get at the subparts. There's some extra spaces there which I'll fix. Alright. This example has one more thing. We're using a function structcopy, which we haven't mentioned. There's a few useful functions for arrays of ASCII codes terminated with zeros, or strings if you prefer. And structcopy says copy the codes from this array into this array. Now if you're thinking, oh wait, I think I could write that function. Yes, you could. It's actually not that hard a function to write if you figure it out. It's only about 10 lines of code maybe. Alright, we're out of time at this point. I'm going to ask Alvin if there's anything in the chat I want to mention. Now, structs we're just starting on, but I thought it was nice to just start on. Alvin.
Yep, I don't think there's anything that hasn't been explained.
Alright. So there's a lot that's unexplained at this point because we're going to, well, we've got a lot to journey on structs, but yeah, we've got a lot to cover with structs, and then we're going to link in structs and malloc, and then we're going to do clever things with structs, malloc, and pointers, leading into the week 8 lab exercises. So, as I said, we're on a bit of a mission here over the next 2 lectures to get across this big topic. So I thought it was nice to show you, it's foreshadowing at least to get into structs. Ethan's asking, can we use string.h in weekly tasks? Yes, you can. You're encouraged, well, unless the task says don't, but you're encouraged to use string.h. We'll come back to a couple of things like that in Thursday's lecture. Alright, so I would encourage you, if you've been inside, to do your COVID safe exercise outside and enjoy the day a bit. I'm going to go for a run later, but if you don't run, walk, some COVID safe exercise outside, avoiding other people except those in your household. I know you've just worked really hard on assignment 1, but I'm afraid you can't stop. This week's lab exercises, they're fun coding, but there's a lot of coding there. It shouldn't be frustrating, but we'll have to spend a bit of time on this week's lab exercises, and pencil in starting on assignment 2, which is lots of work. Alright, so a big thank you again to all the people who answered, all the tutors who answered, well, and the tutors and students who answered questions in the forum, particularly Shrey leading it all and keeping it all happening. So thank you for all the support for assignment 1. Thank you, Alvin, for listening in today. I think Alvin may be listening in again on Thursday. So yep. I'll talk to you all then. Bye, everyone.
Bye, everyone.